Hello YouTube and welcome to my channel. Thanks again for watching this video. Today we're going to talk about VLANs. So what are VLANs? VLANs are virtual local area networks. They allow us to separate traffic at layer 2, and this is like a logical segmentation, a logical separation. A VLAN is a broadcast domain, and what I mean by broadcast domain is these devices are basically a group of devices that are able to reach each other via broadcast. So think of like a broadcast message. And a VLAN, this is a useful way to think about it. A VLAN is equal to a subnet. These are just a few things that you can say about VLANs. They're an important part of infrastructure and used in the enterprise to separate traffic and to just allow communication to happen between switches, and it allows us to extend broadcast domains between switches. So why do we need them? Well, if we look at what communication was like before we had VLANs, if we didn't have VLANs, then we would have to have everything connected to one physical switch. So one switch would be one broadcast domain, and we could not have multiple broadcast domains in one switch. So that would mean that we couldn't have people sitting in different offices and different buildings and then be associated with the same VLAN. They'd all have to be grouped together, sitting in the same area, connected to the same switch, if they wanted to communicate in the same broadcast domain. So having VLANs and VLAN IDs allows us to extend these broadcast domains to multiple switches so that we can still have this communication and not be limited to a single broadcast domain to a single physical switch. We can have multiple broadcast domains on a single switch, and like I said, it allows us to extend it to multiple switches, and it just allows for us to have more effective communication, and it allows for growth. And how is this accomplished? Well, we use 802.1q encapsulation for adding the VLAN header to the Ethernet frame, and 802.1q is the standard now. Back in the day, there used to be other encapsulation protocols that were used. In Cisco, there was inter switch link ISL, but nowadays it's 802.1q encapsulation, and all that means is that there is a 802.1q header that gets added to an Ethernet frame. So if you imagine your just plain Ethernet frame where you have your preamble, and then you have your destination MAC address and your source MAC address. In between your source and what would be your type field is your 802.1q header. Then you have type, then you have your data and your frame check sequence. This 802.1q header is made up of multiple parts. We're not going to talk about everything here, but the important thing to note is that this is a 32-bit header, but the VLAN ID is actually only 12 bits of this 32 bits. So if you ever wonder why there's only 4,096 total VLANs, well, you have 2 to the 12th power, and that's where you get your 4,090 something VLANs, because there's only 12 bits for the VLAN ID. And that brings in all kinds of interesting discussions and problems for large enterprises and customers that need more than 4,000 VLANs. But the important thing to remember is that the 802.1q header gets added in between the source and the type field, and that the 12-bit VLAN ID is the actual ID number, your VLAN ID. That field is only 12 bits. And basically what happens is I have a device connected to a switch, and I have two switches connected to each other. Right, these could be in the same building or multiple buildings, and these two devices want to communicate with each other. So what happens is this device will send a frame. Let's just say this is device A and this is device B. This will say a frame with the source of A and the destination of B, and this port is associated with a VLAN. And what happens is this switch will send the frame out its port, trunk port right here, and it will add an 802.1q header with the VLAN ID that's associated with this port. And it'll go this way. This switch will receive it. It'll receive the frame. It knows what VLAN ID is associated with it. It consults its MAC address table, and it says, oh, that is out this particular port, so I'm going to strip the VLAN ID, and I'm going to send it out this port to B. So this allows us to extend our VLANs. Like I said before, without VLANs, we basically had one switch being one broadcast domain, and that was it. So you can essentially think of it as one switch is one VLAN, and that's all that was allowed to be on there. But now we can have multiple VLANs on these switches, and then we can extend the VLANs between the switches so that these switches can connect multiple VLANs in multiple ports, and we don't have to have that same problem anymore. And that's about it for VLANs and trunking. If you have any questions, please leave it in the comments section. Thanks again for viewing, and have a good day.